Okay, today we have a 19-inch Wells Gardner K4915. This is the medium res version of the standard res K4900, and I'll go over how you can spot that this is a 4915 immediately just from looking at it with your eyeballs. If you, for instance, this one has the original sticker here, K4915, but let's say you didn't have that, you just had a loose chassis that you saw in a box somewhere and you're curious if it was a 4900, 4915, what have you. There's also the K5500, which is the 25-inch standard res of this chassis, and the K5515, which is the medium res 25-inch. Okay, so there's 4900, 4915, that's the 19-inch. Then you have the 5500 and the 5515, which is standard and medium of the 25-inch. And they have their differences. There's not going to go into that in detail in this video, but I'll talk about the visual differences between the 4900 and the 4915 here shortly. But before we get to that, this was sent to me by another arcade enthusiast who said he had one of these off of a necked tube and he had no use for it and asked if I was interested. I said sure, so he sent it to me. He boxed it up, but there was no protection in the box. I opened up the box. When I grabbed it, you could hear stuff rattling around in the box. I opened it up and the yoke was just kind of sitting here on top of all this inside the box, flopping around in transit. The neck board got destroyed because there was no protection for the neck board. Neck board is destroyed. The yoke got damaged. This piece here busted off. And the yoke itself had a bunch of yanked out and moved around windings, which is going to be problematic because these are in a very particular winding method here and they got damaged, and I kind of already tried to put them back, but these things were like bent over this way and all kinds of damage. So I don't know if the neck board got caught up in these windings or if this got caught on a corner of a resistor or something and moved around, but inside the box there was absolutely zero protection for everything you see on the bench. You can even see how this is bent. So they just tossed this in a box, closed it up, and sent it off to me, and didn't bother to protect or wrap or bubble wrap or do anything with this. So we're going to see if we can't try and figure this out here and get this working and do a tube swap. But the major problem here is that we're concerned about convergence because these should be laying flat and aligned properly. You might end up having to use some convergence strips, and we're going to have a lot of convergence issues with things like this. It's not too bad, but along on this edge up here, the wires got moved over, and a whole bunch of these right here that should be laying flat are kind of laying on top of each other, all kind of like this, you know, and it's not going to be good. I tried to kind of lay them all flat, but yeah, I mean, we might get away with something like this, but we're going to try. And even down in here, see down in here, there's these random wires that are just kind of, that's not good. But that's all part of this thing. See this? That's all part of this deal here. So we're going to have to see if we can make this work, but for now, this is what we're dealing with. But it's kind of the least of our worries here for now. For now, we have to try and repair this neck board because it is just demolished. You know, if you're going to send something like this through the mail, at least put some type of effort into, I mean, even snapped this off. This was just sitting here like that when I opened the box, and I think the yoke destroyed this. So we're going to have to fix the neck board at obviously a minimum, and then we're going to have to see and hopefully try and work some magic on this yoke. And then right over here off camera, I have a 19-inch commercial television with a CR23 socket that we can use for yoke swapping and try and make ourselves a working functional medium res 19-inch monitor. Because I do have a Paperboy at the arcade that I've already tried to rejuvenate twice, and then I ended up having to tube swap it because the original picture tube lost all of its red output. The red color gun just died, and rejuvenating it brought it back to life a couple times. It lasted a couple of months, and then it just was beyond usage. And then I tube swapped it, and the replacement tube lost red, and it was the same story with that one. So right now it's running at the arcade with pretty much zero red, and it's time to just replace the entire monitor. So if I get this working, we're going to end up just replacing the monitor and the Paperboy with what we're going to end up with here. You know, hopefully, fingers crossed. But this also came with the degauss coil, or degauss coil, however you want to prefer to refer to it as, but we're not going to need that. I mean, you always have use for this type of connector, so I might steal the connector and put it in my parts bin, but we don't need the degauss coil. Okay, and also in this bag it came with the original convergence rings, but we're not going to use these. We're going to use the ones on our donor tube. Whenever you do a tube swap, you want to reuse the original rings that came with the original tube. You don't want to swap the rings because they're kind of dialed into each individual tube. But yeah, this appears to be somewhat intact. I mean, they're all, I don't see anything really of concern on this. So we have a good set of rings here if we need to use them in the future. And then all the rubber feet here for the yoke. So that may come in handy. But as far as the chassis goes, I'm going to remove this from the plate. I don't think this has ever been removed because the caps are all original and somebody has cut the dag ground off of the, right at the ground, the tube ground around the picture tube, so it's full length here. Normally they're cut right here in the middle to take the chassis off, then it gets wire nutted back together, but it's obvious this has never been removed from a picture tube until they necked the tube. So that's good for us, and the fact that no one's ever messed with it before. Okay, slide this off and we'll set this aside. There's no black or scorch marks on the bottom of this, so that kind of bodes well for us. At least we know that nothing exploded. Okay, so how can you tell just from locking your eyeballs on this that it's a 4915? Well, the 4915 has this special shutdown circuit over here. There's a separate PCB here with a shutdown pod, a protection adjustment they call it. There's also a separate inductor here for your, this is for extra horizontal linearity, I believe. There's an extra width cap because the medium res chassis and monitors like to run a little bit hotter than standard res. So there's extra components here. There's an extra width cap, an extra linearity coil. There's extra components and circuitry here. This is all for our horizontal circuit. All of this stuff here, and then this is for our shutdown circuit. And there's also a little cage here around the voltage regulator. So if you just walk up to one of these, you take a look at it, hook your peepers on it, you see this board here, you see this other board down here with the extra cap and the linearity coil and this box around the voltage regulator. It can pretty much guarantee it's a medium res 4915. This is a dead giveaway here. Now on the 5515, the 25-inch medium res, it has all this same stuff, but it also has a bunch of other big capacitors over here for the horizontal circuit because it's 25-inch versus the 19-inch, which is this. Plus there's an extra resistor here. I don't believe the standard res 4900 has this other resistor here. So they have the resistor, the shutdown board, the extra components here. On the 5515, you've got the extra capacitors over here for your horizontal circuit, for your width, things like that. So those are dead giveaways right up immediately. This is not a 4900 or it could be 5500, things like that. So that's the immediate overview. Now everything else is the same. There are a couple extra components, like there's another resistor across here. There is, I believe, this little extra capacitor here that's not on the standard res. I could be wrong, but I'm pretty sure this is medium res exclusive, this thing right there. Then there's this other resistor here that I'm not used to seeing on the 4900. But for the most part, yeah, otherwise it's about the same. But you can see how dirty this is in here. I'm going to take a minute here and use my brush to put this over the trash can and kind of brush some of this junk out of here. So give me a moment while I do that. It's not that dirty, but I think after we get this fixed, before I do the cap kit, I'm going to go ahead and give it a wash. So, I mean, that's better, but Jesus. God. I'm not sure if this sat somewhere for a while before it got sent to me, but... Okay, and also this is what's known as the 5-pot 4915, if you will. So the standard, there's 3 different versions of the K4900. There's the 3-pot, the 4-pot, and the 5-pot. We don't count the H hold, and we don't count the brightness, if I recall correctly. Yeah, I don't think we count. Well, I can't recall at the moment, but there's a very early version of the 4900 only has 3 pots here. Then there's a later version that has 4 pots. I think the H shift is missing. Okay, yeah, it's these 2 are on all 3 versions. Then there's vertical hold, no, damp, vertical damp, vertical hold, and vertical size, yes. And the H shift is not on the 3-pot. The 4-pot adds the horizontal shift. So the 3-pot has 1, 2, 3, and we don't count the H hold and the brightness. The 4-pot has 1, 2, 3, and then they add the H shift pot, and the 5-pot they add the vertical position. So H shift is H position, and then the V position obviously is vertical position. So 3-pot is these 3, 4-pot is all 4, and 5-pot is the additional vertical position. So you don't have to use the jumpers here anymore. If, you know, long-winded explanation there, but you get the idea. All right, well, we're going to have to work on this neck board. So as far as this goes, you can just take a general overview here, and you can see if you know, if you're more familiar with these than I am, you know, you got more years experience, then you can spot maybe something and comment down below. But you can see this bodge wire here coming off of this vertical resistor, or vertical section resistor, and it runs up here to our shutdown circuit. The red wire runs to this side of R204. Yeah, I don't have the knowledge of how this circuit operates, and of course we have a ground, but it's obviously working for a shutdown, like I say, because these run so much hotter than the standard res that they do all this extra circuitry. Now I also will say that the horizontal width coil is a different part number. If I recall, this is the part number off of a K7000. You can see here that we have 9 alpha 2838-002. And if I grab my bin of K7000 parts, and we probe around in here, I think I have, what is this one? Yeah, there you go. 9A2838002. So the medium res K4915 uses the same horizontal width coil as the 25-inch K7500. So that's, of course, understandable because the 4900 one is much smaller. And again, I think because it runs so much hotter in the horizontal circuit, they need a beefier width coil. But of course, there's inductance as part of that. And they need the proper inductance for the circuit to work properly. So I don't know the logic behind why they use the 25-inch 7000 one, but this is a 25-inch K7000 part number, and they've got it here on a 19-inch 4915. So anyway, I'm pretty sure it's 25-inch. Could be 19-inch. You know, if I'm wrong, correct me. But regardless, it's a same part number as a K7000 width coil. We'll go with that. Well, let's look at the bottom side and see what we're dealing with on the bottom side here. We'll zoom in a little bit, and I don't see any cracking on our AC jumpers, so that's odd, but nice to see. And of course, we have cracked joints on R311 in our vertical circuit. That's always common, super common. Also on R312, those two joints are very bad. But I'm sure if we were to just turn this on, it would work. I don't see any other real issues on the bottom side. Out of curiosity, let's go ahead and check our fuses. I'm not in continuity mode. Okay, fuse is good. I say fuses plural because I'm used to working on the G07, but there's only one fuse, and that's good. So I think if we were to turn this on, it'd probably work okay. But we're not even close to that point yet. Right now, Next thing on the list is to try and repair this destroyed neck board. So let's see if we can kind of work some magic here. We need to... Well, I seem to be missing my diagonal cutters. I'm not sure what I did with them. Let me go hunt those down real quick. Okay, I found them. I had them downstairs. I was working on, or doing some repairs to my Back to the Future pinball machine, and I forgot that I had them down there, but okay. We need to cut this off of here. And I'm not going to reuse this, so we'll just throw it in the garbage. Okay, let's take a look here. Now, I've done this many times. First thing we need to do is kind of glue this back together. Something like... okay, so this resistor has come out of the joint, but... First thing we need to do is kind of glue this back together, something like, doesn't have to be perfect, but something like this. Well, and then we'll have to wait for the glue to dry and repair all these traces, things like that. Now, I think Peter at Arcade Parts and Repair has a replacement 4900 neck board, but for the purposes of content, we're just going to go ahead and fix this one. So, all right, I'm going to grab some glue. As a matter of fact, yeah, it's out in the garage. Hang on 1 second again. Okay, I found it. Boom. So let's get rid of that and this. I'm going to turn my fan on here so I don't breathe these fumes in. And this is a gel as opposed to a liquid, so it's a little bit harder to get to come out here, but it works a bit better in my opinion. Shake, shake, shake. Shake, shake, shake. Shake your glue out. Shake your glue out. This is... Oh, well, now I see what the problem is. The whole thing is dried up. Well, that doesn't make any sense because I had the cap on there. Well, that'll put a kibosh into our plans. Oh, no, it's fine. It's just kind of crystallized here. Well, that's weird. Huh. Well, I guess... we'll do it like this. I don't know. That's weird. I mean, it'll work, but it's just kind of weird. Wipe that off of there and stick this on here and make sure it's sitting flat and flush. And I'm going to pause here, hold this on here for a good 5 minutes or so, and then I'll come back and we'll attach the other part of this. So hang on a second. Alright, so this piece is now secured in here, and before I try and attempt to put this one on, I'm going to fix all this first. So if we zoom in here, we're going to have to do some scratching away, and we can see that this trace here is supposed to connect together. So we're just going to do this. Using my fiberglass scratch pin, which is real fiberglass. This is used to etch off paint when doing automotive repairs. So you've got that one. You can see that this trace is supposed to connect, so we're going to scrape off that one. We can see that, Alright, we can see that this trace here, even though it's filthy, there we get rid of some of that dirt there. That is also supposed to connect, so we're going to get rid of some of this here. There we go. So there's 3 of them, and we can see that this is supposed to connect together. There's a crack through there and there, but we can solder bridge that back together, as well as this here. And then we'll have to do this once this piece gets in there. And that should be all she wrote for that part. And I'm going to use my brush here and brush all this off into a trash can, because you do not want to get these fiberglass bristles. See, this is real fiberglass as opposed to those ones you see on Amazon for like $8 or whatever they charge. Those aren't, I mean, they may work, but they're not real fiberglass. They're like a, they work for what they are. I'm just not a fan of them because I bought a couple of them and they didn't do anything near as good a job as this one does. So I'll link this down in the description below, so you can grab one. And they do have, I mentioned this before, but they do have a little cartridge refill. You pop this cover off and there's a refill inside of there, so when this one runs out, don't buy another one. You got a refill inside this one. Okay, so now that that's done, we can actually just apply a solder bridge across this, like, oh, stupid iron. I turned it on in anticipation of this part, and then it went to sleep. I normally keep it at 800 degrees Fahrenheit, which is nice hot iron, so you can avoid having the tip oxidize on you when you work on it. Now this looks oxidized because it got hot and I hadn't cleaned it off yet. Once it gets up to temperature, you can see how dull this is. Once I clean it off, it'll be nice and shiny. So right now we're up to 600, so let me see, now it's shiny. So let's just go ahead and bridge this across there, and there you go. So that one is now done. These here, we can do the same thing. We'll just bridge across here, like so. Same thing here. Well, if I can, you can even see what I'm doing here. We got to add solder to this, and just to reinforce it, we're going to go to this pad here. These are the heater pads here. There's that one, and we'll go through on this. There we go. All of this is together, by the way, so we can just kind of do something like that. It's not pretty, but it'll get the job done. All right, now for this over here, we can kind of do the same thing. I think that'll work for those joints. Let's take a quick look overview. We got this one. We got to do these two. Got that and this. Is that broken across there? I don't think so. Nope, that's fine. All right. Of course, we'll do the reflow on everything else later, but I mean, yeah, that's not. It doesn't look very good, but it'll work for what it needs to be. So, or work for what it needs to do. I think that's good. The rest of this broke on top of the heater pad there. These two traces are for our heater. This is our heater ground. This is our heater voltage, 6.3 volt for a heater circuit. So that's what those are. Then you have KB is blue, KR is red, KG is green. That's our G2 voltage. And then we have our focus right there, so our focus voltage. Anyway, well, that's how it should be anyway. If I'm wrong, yeah, someone out there can correct me. But like I say, we'll go through here and do all this reflow later. But I don't want to forget that focus one, so there we go. Okay, yeah, and they removed the G1 here, and this is part of the medium res mod 2, if I recall correctly. See how they got the G1 pin pulled out? They soldered this wire in there. That's part of the medium res option too. Okay, so now with that done, we can glue this part in, and I've been leaving this sitting up, so I should be able to do it the way it's meant to be done now. Yes, there we go. Along here. Or I thought I could anyway. Got it. Alright. So let's make sure that resistor goes through the hole. It does. Now we can set that in place, and man, that goes back together very nicely. So again, I'm going to hold this for about 5 minutes and cut away. And I'll come back and then we'll repair all of these small traces with some jumpers and these two over here, and this should be back in business. So stand by for a moment and we'll see how this turns out. Alright, so mission accomplished on this. To save a little time, I went ahead and already etched off the traces, or the mask, the shadow mask. I'm thinking of the tube. Not shadow mask, solder mask. Already scraped off on all these joints, so we're ready for fixing this up. And I think for this crack across here, we can just do a little bit of solder bridging, or just reflowing this joint here, and maybe nothing goes there, so we should be able to just kind of add a blob of solder across there, just like so, and that should reconnect meter and continuity. That should reconnect this to here. Let's go over to here. Well, it's just, there's crap on here. Let's just get rid of the crap on here. Now that should be, there we go, boom. So that's restored. This whole trace here is restored up to this point. That's all we should have to do for that. And for up here, we can do more, just some more bridging. Heat that up. And this resistor, I did have it in there, but it came out when I just heated that circuit up. I know you couldn't see, but it was this resistor here popped out. So I guess what we can do before we get too far into this is try and tack that back in place. So the connection's a little oxidized, so I'm going to try and scrape away some of the oxidation on the leg. Okay, that's good, but we need to... Alright, I think that's a little overkill, but it'll work. And... yep, that should be fine. Alright, the only thing left now is... well, actually, I got sidetracked, sorry. I got sidetracked. We can do that, we can do that, and should be able to, bam, just like so. Perfect. And tin this up. This should jump across there very nicely, just like so. And I'm going to put a little flux on here. That's better. I just kind of wanted to build that up a little bit, especially across here. I think that's better. Okay, so those are now done. All that's left now is this and these two, if I don't have deceptive eyes. So for those, I mean, I could just solder bridge across them, but I was going to use some component legs, but if I didn't use component legs for the rest of these, then there's no reason to use them for those. I think what we'll do is I'll just try to bridge these normally first here. It should work. Use a little flux and we'll just try to do it this way. Actually, I think this flux is hindering me. I'm not going to use it next time. Yeah, this flux is actually hindering me for what I'm trying to do here. Yeah, that is not working. I'm going to get rid of this stuff. Okay. I might just end up having to use a component leg after all. Now, I can hear you screaming at the TV or whatever you're watching this on. You know, I should be using a component leg anyway for strength. But if this gets bashed again, component leg ain't gonna help it. So, usually the component leg's required when you can't bridge the gap. When there's too big of a gap because of the crack or the break, you'd want to use the leg. But if you're able to actually expose the trace there in between, which a little bit of glare there, sorry, I should be able to just kind of go like, boop, there we go. Yeah, that flux was not my friend on that one. But there you have it. It's bridged. It's going to be good. We're not going to worry about it. So these up here, I'm not going to even bother with that flux because it didn't help me one bit. Okay, now we'll try this again. Well, that worked, but I don't like it. Well, that worked. That's not bad, but this, a little too much there. All right. There we go. I think that'll work. So those should work for what we need to have happen. Okay, it doesn't look that great, but you know, if you don't have any component legs at your disposal, that should work. So I'm going to clean this up here. Actually, before I do, I'm going to do a little reflow because this is all messed up over here, this connector. So we need to kind of set that back in place and reconnect the connector, and it goes this way. Got it. The missing wire goes to pin 2, so that's good. Alright, let's do some reflow, then we'll clean this up and test all of our connections, and that should be it as far as this goes. And we can knock this out fairly quickly. These 3 capacitors here I think are exclusive to the medium res 4900 also, or which is 4915. Okay, anything else? The rest of this all looks pretty good. I think that should be good. Okay, so now let's point the fan the other way so it doesn't vaporize my alcohol, and we will clean this up as best as we can with a little denatured alcohol. Wipe it off, and I think that should be good. So what I want to do now is go through with the multimeter or multimeter, depending on what part of the country you're from. What part of the world you're from. Alright, so this should all run through over to here. Yes, and then down through to here. Yep, and that. So that's good. This should run up through to here. Yep. Yep. Whatever color transistor this is, we simply would not have that color if it didn't work. It looks like it runs to blue. So if this doesn't work, we're missing blue. You can see it goes to KB, that's blue. And that runs up across R415 down here to this transistor. And this one here is for green. So if we're missing green, it's this one. So this should run through over to here. Yep, and to here, and to there. That's good. So these three are fine. Next would be this one, which is obviously going to work. That's red. This is our heater. This is our heater positive. This is our heater ground. We already did blue. And so that one's good. That one's good. This one here comes around to, if this doesn't work, we're not going to have any positive heater voltage. So we'll check that. That's good. As a matter of fact, let's reflow that a little bit. It's a little bit dark. Okay, that should be all right. And this doesn't matter because this just goes up that way. There's nothing on 2. 3 goes to here. 4 goes down to here. I think that's it. So that's one repaired neck board. Let's wipe our pots back and forth. Let's spray a little contact cleaner on them. And let's wipe them back and forth and set them to center position. And let's make sure that everything is intact here. This is all bent to heck. Okay. That's one repaired neck board. So we can move on to, I guess, let's do our light bulb test for our main chassis here. And if you're unfamiliar with this, what this does is this tests our voltage regulator and our B+ circuit to make sure that our voltage section is good. So we need to remove our HOT, and by doing that we prevent the horizontal output circuit from energizing. And we can run this on the bench. And the HOT is over here, obviously, by the flyback. Your HOT is always in the area of your flyback. Your voltage regulator is always in the area of your AC input. So if you don't know which one's which, that's how you can always tell. So we can just take that right out. Now we can attach a light bulb to the blue wire, if I recall, of our B+ resistor. Now on the standard 4900, this resistor is much smaller and it's actually over in this area. But because this is medium res and runs hotter, you need a larger resistor here. They even have to put an extra one on there because they're tied together, I believe. But yeah, on the medium res 4915, it's over here, which you can't even see there, I'm sorry. And then on the regular 4900, it's actually in this area, but it's the same type of thing. You go to the blue wire, if I recall correctly, and we'll just kind of tap onto ground here. And I could be wrong, it may be the red wire, but you can see here we're attached to the blue wire. So, all right, now I'm not necessarily worried about what our voltage is going to read, but we'll hook it up anyway. Whoop. Okie dokie. Smoky. Now we'll connect the positive lead of our meter to blue as well. And we'll hook this up to ground as well. And I think we're supposed to be around 123 0.3, something like that. I can't remember. It's been so long since I've done a medium res, I'm not sure. But we're just checking to make sure it does turn on. We don't have any kind of problems. That's all we're interested in. And if the B plus is stable, hey, that's even better. So we got volts DC. Now I got to try and figure out what kind of butchery is going on here with these power wires. This one's all dirty, but just for testing purposes, we'll actually, you know, let's grab a couple more alligator clips and we'll do it the proper way. I say proper, depends on your definition of proper, but what I mean by that is we can just clip onto the wires and then take our lead, put that in there, and put that in there. Make sure these aren't touching. They're not. Everything is good. All right, let's see what happens here. 1, 2, 3. Yes, light bulb works. We got 122 volts. That's about right. So I think we're good. Our power supply, voltage regulation, all that's good. So we can eliminate that as a possible cause of an issue later on down the road. That's why it's important to do that. Now with the light bulb, it's important to note here that if we turn this on and it didn't light the light bulb, you're going to have to manually discharge the filter cap. But with the light bulb hooked up in the circuit, the filter cap has automatically discharged due to the load on it by this. So it's safe to handle now. If you try this and light bulb doesn't light up, then you'll have to manually use a screwdriver and short the two contacts before you handle it so you don't get a little zap. Not to say you would, but it's always a good idea to do that. Alright, so with that done, we can now focus our efforts on this yoke and this tube swap. Let's get our HOT back in. You know, we can go ahead and test it, I guess, while we have it out. We'll go to our diode checker. We should see a 0.5 voltage, 0.45-ish voltage drop. Negative on the base, and then to each leg should be about 0.450 voltage drop. 0.47, that's fine, and 0.49. So, should be good. You're just checking to make sure that it's not shorted. And yes, there is an insulator there. I couldn't see the insulator, but it's there. So we'll plug that back in. If there was no insulator, that fuse would not have been good. And this same thing applies to the 4900 and the 5500 and 5515. It's the same procedure. Just take out your HOT, hook up to your B plus resistor on the blue wire, wherever it's located, whether it's here or back there, and that's all you have to do. If our light bulb didn't light up, we'd have a problem with our rectifier diodes or either one of our B plus resistors, the little one or the big one, or various capacitors, but it's easier just to do that, and if that's good, you don't got to worry about and go waste time testing 100 other components. Okay, so with this now done, oh, I'm sorry, I forgot. We got to reconnect this. We don't want to forget that. I still have to, you know, clean this and cap it and reflow it and everything, but initial workings on the main chassis itself are complete. So I'm going to set this aside, and we're going to grab our replacement tube and do a little deconstruction and hope that this works. Now, with this yoke here, I'll zoom in a bit. Let's get our meter. Actually, you know what? Let's test this just to make sure it reads properly. So, for our vertical winding, which is the yellow and the green, we should see around, I think, 12 or so. No, I'm sorry. We're dealing with a high impedance yoke. 42, around 50. Around 50, give or take. That's good. And then the horizontal blue and red should be around 2 ohms or 1.5 to 2, something like that. 1.1, that's probably okay. You're just checking to make sure it's not wildly out of tolerance, but around 2 for horizontal and 50 for vertical, that's about what you want. We got 1.1 and 43, so yeah, I'm happy with that. So okay, just checking to make sure that we don't have an open winding is all I'm interested in, and that's good. So now what's supposed to happen here is this is supposed to clip clip on here, and there's two sides to this. They're both broken. This is supposed to clip in there, and there's supposed to be another clip right there, and it's gone. I mean, I can probably glue this in place, which is likely what I'll do. And then this here is supposed to have another clip thing here for this to clip onto, but it's gone. So I'm not sure how we're going to do this really to kind of keep the the tension on this. I may have to kind of epoxy it right here, which I could do that. I could just epoxy this right there, which is what I may end up doing. I think I'll do that. I think I'll probably glue some of this in place and let it work its magic while we work on this picture tube. I'm trying to not let any of this touch what it's not supposed to. Not that it matters, but because this all goes together. Yeah. All right, well, I think I'll have to probably just epoxy this like that. That way everything stays good the way it's supposed to. And I'm hoping this is going to work. If not, this is kind of all a futile effort. I can repair the chassis and hook it up to a standard 4900 tube and even a G07 tube just to make sure it works and functions and everything's okay. Just for like quick 5-minute testing, it'll work. But we can't hook it up to that and leave it hooked up because it'll damage both the chassis and the yoke over time, and it won't take very long. But I think I'll have to just epoxy this in place like this and then kind of just leave it. So let me do that. I'll do it off camera, and then I'll come back and we'll start tearing this other TV apart and check it out. I haven't taken it apart. I'm assuming I did see a CR23 through the hole, the vent holes in the back of the casing, so I know it's the right one. But we need to take it apart, obviously do a little bit more closer inspection. So let me get this epoxied. I'll come back and we'll get this TV apart and take a look. Okay, so I have the TV decased here. This is the original chassis that was in it. It was just an RF only, very cheap, bottom end, 19-inch Orion tube. But as you can see, it's a CR23. And we're going to take this yoke off, see if we can work some magic here. So the model number of this TV, not that it matters because we're changing the yoke out, but it is a, can I get this in frame here? It is TV 1929, Orion TV 1929. Okay, well, manufactured September of 1999. Now, just to show you that we cannot use this yoke, obviously we couldn't anyway because it's a standard res yoke, we got a medium res chassis, but the windings on this one are, I guess we just go right to here, yellow and green, 13 versus 50, and the horizontal is probably still around 2. Oop. Any day now, had it. Nope, nothing's easy. 2.5, yeah, so can't use it even if we wanted to. Okay, so what we need to do before we start here, oh, I forgot to show you. The yoke itself, I glued this back in place here, and this one had the clip, so this is nice and secure. Now this side, I made the mistake. It turns out it's supposed to be sitting on here like this. That's how it really should be, so I just kind of glued all this in place, and it's nice and secure, won't go anywhere, and got the wires, all the slack taken out, and the inside is there's a little bit of slack there, but it shouldn't really affect anything, hopefully. So there, that's better. Okay. Yeah, so I think we're ready for that. Before you do anything when you do these tube swaps is you want to mark in multiple places the original position of the rings. So I have a Sharpie here, and we're just going to take these rings here, and we're going to make a mark on the retainer ring here as well as the tube. And then we want to make a mark with the rings, so it can line everything exactly back up where it was when we're done. Let's go over here this way, and we'll put a mark here. I say multiple marks because when you take these off of here, they're going to get, your mark's going to get kind of taken off but we're marking there, and we're marking the tube, so we have it marked here. We have it marked here. I'm going to make one more mark along the bottom here. Actually, probably we'll do it over here. So I'm going to make one more mark, like so. And now we can, when we go to put this back on, it can go back on in the exact same position. Okay, then that will limit our need to really work on convergence. So we know if we have convergence problems later, it's a yoke position issue, or we have to use some, see there's some factory convergence strips in here that we'll have to probably just take off and worry about later. But okay, now that that's done, we can successfully remove this. That's the wrong size, so we'll go with our Phillips head. And this should come off here, hopefully fairly easily. Sometimes it's been on here for so long, you kind of have to give it some crystal blue persuasion. But not too much. Oh, there we go. Broke free, and come on. Come on. This tape they have on here, fantastic. There we go. Off and intact. So nothing moved, and everything is lined up. Also, part of the reason you want to put those lines on here is to make sure that if it does move, you can align it back to where it was. So that's all set from the factory. That's why you want to do that. And you want to keep the original rings that came with the tube So we're going to swap the yoke, but reuse the original rings. So this should come right off as well. You just loosen up the retainer, and this should just slide right off. Now here's where it can rub your marks away, so you want to kind of just as fast as you can take that off of there, and there we have it. Awesome. And this should just go right on. And I'm not sure if it goes, I think it goes this way because of the number, but we can always just flip our yoke connector around if we need to. And I'm going to take these convergent strips off of here, and we'll use our own new ones if need be. But this has the feet here still, you can see them there, so we'll reuse the original ones and slide this on here, and with any luck we should be able to have this work first try without too much difficulty. You want to make sure this is sitting as far up against this as possible. Make sure it's not crooked one way or the other, and it looks like it's sitting a little bit too far this way. You can tell by the way that it is. And I want to kind of, that's a bit better, I think. And then you also want to make sure it's straight, not turned one way or the other. We'll have to make adjustments later, but for now, with it pushed all the way forward, we're going to tighten it down. Not too tight, obviously, it's glass. And then we're going to slide this back on in this position. Just like so. And there we go. Now this should go roughly right there. Excellent. Perfect. Perfect. Okay. Having the indentations in the tape helped out, but that's probably one of the smoother swaps I've done. Okay, just make it good and tight, that's all you need. And I'll hang on to this yoke because there's no reason that I can't reuse this for a 19-inch CRT, CR23 really is what I meant to say, in the future for a 7000 or something. And there we have it. That's about all you have to do. Now we can just directly connect our chassis. We're not going to have to worry. I guess we can swap. We can swap the degauss connector. This is for our degauss coil, and of course it's a different style connector. We don't need the degauss to actually test this, but I am going to go ahead and just kind of hack this connector off of here. Actually, let's get a little bit of slack on this. Let's go here with it. And I'll just kind of splice this in later down the road so we can hook the degauss up and down later. We don't need it for testing at this moment. And our ground, again, we can take the ground wire from the chassis, strip it, and solder it directly to, because we don't need this either. We can solder it directly to the ground. So I hacked this off here, and I'll save that connector. So for the chassis here, I do want to go ahead and reflow these joints here in the vertical output that I had pointed out earlier, just these two resistors. And of course my iron went to sleep again. So it goes to 360 degrees when it goes to sleep. So now we're up to 500 already. That should be okay to reflow R312 here. Alright, yep, that's good. Okay. And now I want to hit R311. All mixed up. Don't know what to do. Alright. That's all that I really need to do at the moment. Okay. And we should be able to flip this around. Now I don't have a frame for this, so I'm going to have to either make one or wait for another monitor to die or something and rob that frame. I don't have a frame, but it's not important. If I can get this to work, at least we'll have a good tube that we can use. The ground wire I mentioned, we can go ahead and just strip this. I don't have my strippers up here, so we'll do it the old-fashioned way. If you want to yell at the screen, you can. That works. We'll add some flux paste to this and try and tin that up. And you won't be able to see, but I'm going to solder it to the dag wire on the tube. Alright, that's nice and good. So I'm going to solder this to the dag wire, and I'll just desolder it when we go to disconnect this. Because it's already got some solder on here from the wire I cut off. So, okay, that's good. I probably could have just used an alligator clip, but that's okay. Actually, you know what? I am going to do that. I'm going to clip on to the frame. I'm going to clip on to the dag wire and then clip onto the frame just for an added security. Now the flyback wire here, I'm going to have to anode wire and take that knot out of there so I can reach the top of the tube. And then there's this little metal clip in here that aids in your conductivity, and it's supposed to keep this from moving around, keep it secure on the anode. I just take this thing off because it's always a hindrance to me. I just take it off and throw it in the garbage. I never use them. If you want to complain, you can complain, but there's no reason to use those, in my opinion. But I'm going to clean the inside of this because it's all dusty. We don't want this to static shock us by leaking voltage out around the anode cup here. So that's better. Now I'm going to connect this to the tube. As you can see here, you put one end in, you put your other end in, make sure both are in, and boom, that's on there. Okay, now we need to, shouldn't have moved the camera. We need to connect this to here, and I want to push with my thumb here, not with my finger, so I don't break it again, and boom. That's on. So we have our anode connected, neck, yoke, ground. There's no remote. I need to hook up power, and we need to get a video signal. So this is going to be fine just sitting like that. As far as power goes, we can grab a couple of alligator clips like we used before. And I'm going to clip on here. Actually, we'll go the long way. Take the long way home. Dun, 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 dun. I was lonelier than Kunta Kinte at a Merle Haggard concert that night. I strolled on into Uncle Limpy's Hump Palace? Uncle Limpy's Hump Palace, looking for love. It had been a while. Alright, if you know what that is, props to you. Uncle Limpy? Is it Uncle? I forget what it is. It's been 20 years since I've heard the song, but okay. Uncle Limpy's Hump Palace. Okay, so now our power is all connected, and I think we'll just spin this around. I'll take the camera off the overhead, and right now I'm only interested in whether or not this turns on, and I'll turn up our raster and everything, and when it turns on and operates, then we'll give it a video signal and see what we get. So hang on a second. Okay, so we've got our power here, and those are safely apart from each other, and again we got our anode and neck and yoke and ground and everything's connected. This is all we should need to at least turn it on and see if it works and what we get. So here we go. 1, 2, 3. Okay, we get high voltage, and there we go, it works. We do have some, I don't want to say this is purity, I'm not even sure if you can see it, but it is working. Yeah, this is the original yoke, so I'm not sure why the screen is so, we got like an inch of black here and an inch of black over here. Not sure why that's happening. Could be because there's no video signal. Let me give it a video signal. Let me hook up my Cruisin' USA board real quick. Hold on. Okay, Cruisin' USA is connected. Obviously medium res. So let's turn it on again and see what it looks like now. 1, 2, 3. Okay, the 4900 doesn't discharge. And, oh, well, for crying out loud, I forgot to connect the video signal. Let's spin this around, make sure none of that touches anything, and we'll plug in our video signal. Make sure we're free. Yep, okay, and there we have it. And, oh hey, we have full raster. Okay, well, we have full raster, but we need to do some major adjustments here. Vertical hold. Well, let me just get the camera on the tripod and we'll work on it that way. Okay. Now, which one of these was hold? I think it was this one here. Nice. Okay. We definitely need caps. See these bars across the top here? I don't know if you can see that. I need to use, you know what, hang on, let me use my iPhone. I forgot that this camera doesn't play well with the refresh rate. All right, I have to zoom in a little bit, but we're on the iPhone now. You can see it still has the refresh thing, but it's a little bit better than it was. At least you can actually look at it without getting a seizure. So initial indications are that our convergence is pretty good. It looks pretty good right out of the gate. But we do need to adjust H shift, which is this one. Oh, hang on. Our brightness is way too high. I mean, all kinds of stuff here. Let's do this. Okay. Oh, that's H hold. Turn our brightness down. Okay, a screen pot's too high. Let's turn our screen pot down. That's better. Now we can turn the brightness back up. Oh, that's H hold again. You liver lily galoot. Okay, not bad. We're too red. Gotta turn our green up slightly. And yeah, this little collapse up here, that's caps. And all these jail bars, and we gotta recap it, but if anything, we need to turn the brightness down a little bit more. Right about there is where it should be. Let's see if we can hit a little bit of focus here. Ooh, that looks good. Now I can hear you saying, wait a minute, this is not a medium res picture tube. Well, you're right. The dot pitch is not going to be medium res, but the average person if you didn't know I was doing this, you would never know that this was not the original medium res 2. To the naked eye, in my opinion, no one's going to even notice or care. But initial indications are that this is really good. This might be a successful swap. The world's first successful yoke swap without having to adjust anything with convergence. That's why it's so important to get the yoke set up right and get the convergence rings back in the spot where they were. I mean, I don't see any convergence issues whatsoever. Let me pull out the test pattern generator here, and we will attempt to do this with the TPG. So let me see about, turn this off. Let's disconnect the PCB video. We'll hook up the TPG video, and there we go. Set that back in place. Put this on medium res, which it already is. Turn it on and connect that. And let's see. Oh, we're gonna have to adjust each hold, it sounds like. Yep. Oh. What the heck? Well, that's weird. I had it there for a second. Let me play around with it. Hang on. Okay, I figured it out. The wire, sync wire, came out of the connector. But now we're back in business. Okay, so just looking at this now, it's amazing to me. I'm not sure why it looks so dim through the camera, but anyway, in person it's a lot brighter. Look at this. The convergence on this is basically absolutely perfect except for up here, but that's because it's normally like this. This is a TPG issue, but it needs caps and reflow and stuff, but it's working. As far as convergence goes, let's go to the convergence. See, all of our RGB is even. All this is even. Now there's a little bit pinkish here, a little bit pinkish here. Probably you can see the pinkish here. But if we go to like an all color here, see, you can definitely see over there and here. It probably is a degauss issue, but I might need to move the yoke around, but that's a purity thing. And I can adjust that with the first set of rings. If I loosen this up and I move the first two set of rings, you can see here how this changes. But I don't really want to mess with it because it might just be a degauss issue. So I'll put this back exactly how it was. There we go. Lock it back in place. So, I mean, I can take you don't really want to do it this way because you run the risk of damaging the shadow mask. But you can take a decent size speaker like this and you can see what it does there. I can just sit here and go like this. See, fixed, gone. And I don't have a wand with me. Look, see? And it's not perfect, but there, see? Fixed in 2 seconds with the speaker magnet. Yeah, so I think it was just a degauss issue. But there you go, fixed, 2 seconds. RGB is nice and good. Here's our convergence. It looks fantastic, except for up here in this corner. But I'm not going to worry about that too much until we really probably do the cap kit and everything. But for the sake of content, let's see if I can zoom in on this. And maybe, oh, yeah, look at that. I mean, I don't have to touch anything. Our white dot in the middle is white in all areas, and it's really pretty sweet. Right off the bat, the world's quickest and easiest yoke swap you'll ever see. I'm sure some of you are probably disappointed and wanted to see some actual convergence and stuff, but right here on the top here, we're going to have to worry about this. Now, I can't really mess with anything without affecting the rest of it. So what I think we're going to do here is get rid of this Cruising USA board before I slice the corner of my face open. I'm going to try and get a convergence strip in here. And if you're unfamiliar with what those are, it looks like, well, I'll zoom in and show you later. Or zoom out and show you later. But can I get one of these in here? The yoke is too close to the... Yeah, the yoke is too close. I might need to actually back it off a bit. And that might... Yeah, that's down there. I'm going to back this yoke off ever so slightly, because I think it's actually too close to the tube. I'm going to move it back just slightly. I think that should work, and it didn't really sacrifice anything. It is still twisted slightly, but I want to see if I can stick a... That's better. So you see what's happening up here? I think that's an artifact of the actual TPG, and not necessarily... Oh, look at that, boys and girls. Ooh, ooh, man. If I take that convergence strip back out, there's our convergence. Not good anymore. Now, if I take this convergence strip and put it back in, and trust me, I'll show you here in a minute. You'll see practical application. There you go. I mean, that's all you need. Now, if I zoom back out of this, oops, sorry about that. And go down. That is amazing. One convergence strip, fantastic. I can't believe it. Now we need to try and turn our yoke slightly to where this is somewhat even. I think that's pretty good. Now I'll tighten it back up with that screw. And the only thing left for this is going to be... Oh, that scared me. So my screwdriver is magnetic. You'll see if I get it back here near the convergence rings, it goes a little haywire. So I'll just tighten this up. When I take the screwdriver away, it goes back to normal. But our convergence is perfect. Unbelievable. All I did was one convergence strip and a little bit of pushing the yoke back a little bit, and bam, we're good to go. Let's keep out of here. Okay, nice. Now I want to hook my cruising board back up now, and we'll swap over to it. Oh, lost my Kimwick, or Chipquick, my flux I was using earlier that didn't work out for me. So now I'm going to hot swap this over to the cruising board. Oh, now we have to readjust H hold because it's never the same. There we go. H shift back over. Well, that's as far over as it goes. Let's supplement with a little more H hold adjustment. That should slide it over that way. Nope, doesn't like that. That seems pretty good. Let's see if we can adjust our width coil. And I'll just get the adjustment tool out here and see if we can adjust this. Okay, we are in there, and oh yeah. Nice. Okay, we're going. And that's about all we get, which is fine. Now if we adjust our H position a little bit more. Nope, it doesn't like that. Okay, that's all we get, but that's pretty darn good. Let's see if we can add a little bit more. We don't want to add more brightness, but we might want to turn up our blue and our green and our red slightly. Now that looks amazing. Well, it's too bright. We need, see these lines here? That's caps. It's collapsed at the top a little bit, and there's these horizontal lines. There's these vertical lines. Those are gel bars. It needs caps, but man, let's turn our brightness back down a little bit to where you want the background to be black, right about there. You know, good enough. So I'm going to do a cap kit. I'm going to do a reflow, and we'll come back and we'll test it one last time, and then I'll have to figure out, this will be tied together now forever, and I'll do the degauss cable swap, and then I'll have to at some point find a frame, but at the very least we now have a working medium res 4915 with a successful, unbelievably easy world's quickest and easiest tube swap, a yoke swap I should say, because tube swaps are easy on themselves if you don't have to swap the yoke. When you gotta swap the yoke in the rings, it gets pretty tricky, but that's why it's important to just go back with the original rings that came with the tube originally, and I didn't have to adjust anything. I had to move the yoke back a little bit to get the conversion strip in there, and one conversion strip. And even then, we really probably didn't even need it. You would never have noticed it, but anyway. So I'm going to get the rework done. We'll test it one last time just to see how it looks afterward, make sure our collapse the top's gone, make sure that our gel bars are gone, and we'll see how it looks after that. So here we go. All right, so all the rework is done. Cap kit, reflow. I did not wash it because I don't want to wait 24 hours for this to dry before I use it. I want to get the video done and uploaded and everything. So after everything is tested and working, I'll go ahead and give it a wash and a cleaning and then add it to the inventory. But it's all done. Everything checks out. I did a full reflow, including all of the components in the power supply. The AC jumper here, the AC jumper here, the AC jumper here that likes to have problems. The video input header pins, our vertical ICs, everything in the vertical output circuit, anything and everything that looked like it needed reflowed has been reflowed. It's all good to go. The neck board, as you saw, obviously had been successfully repaired. So there's not much to it when you have to fix this. You saw the procedure and everything works fine. Ideally, you know, if you want to put some jumper leads in there with component legs, you can. But if you do a good job reinstalling everything, gluing it all together, making sure it's nice and secure, you really don't have to worry too much about that. It's kind of a judgment call. I could have used jumper leads from component legs, but you saw I didn't, and it's not really necessary if you kind of, well, I don't want to say, you know what you're doing, but if you know what you're doing, you don't really need to use those if you make this nice and secure with the glue and all that. So obviously that's good to go, and it's ready to test one last time. So I'm going to get it hooked back up to the tube, and I'll probably go ahead and make all the adjustments and settings and get a nice, good, solid picture, full screen, everything. And then I'll go through and show, hopefully the lines on the top of the screen are gone. Its vertical size is good. Hopefully the recapping it fixed, gave me a full horizontal size and all that jazz. But I did shift the horizontal centering jumper over to the left because we did need to move it to the left ever so slightly. I had the horizontal shift all the way over and H hold all the way over to where I had the most left control before it started to go out of sync. So I moved the jumper over to the left to try and get a little bit more position. We'll see how that goes. But let me get it back on the tube, get everything adjusted and all that. And I'll come back and we'll see how it looks with all the rework complete. All right, well here it is, all adjusted, everything working fantastic. There is still a little bit of jail bar issue here going on. Now, I don't know if that's in the horizontal circuit or if that's part of the flyback or there's a failing polycap or resistor going out of spec. That's kind of out of the realm or out of the scope, I should say, of this video. I might come back to this in the future. I still have to find a frame for this and a setup, but this was just to do a tube swap, to have a tube to go with that chassis once we fixed it and all that. So I have a full setup now. I just need to find a frame, but I'm still kind of perplexed about these jail bars. I may troubleshoot that in the second video or follow up to this once I find a frame and get all the stuff in a frame. But otherwise, it looks great. Colors are fantastic. It doesn't look very good in the camera, but it has very nice focus. You see here, if I zoom in a little bit too far, it kind of goes out of focus because this camera is a piece of junk. Oh man, there we go. That is crisp. Okay. Wow. Super. I mean, this is a standard res dot pitch tube with a medium res yoke and chassis. So yeah, if we could just figure out those jail bars there, I thought the electrolytics would fix that, but it didn't. But otherwise, yeah, colors and focus here, you stupid thing. There we go. Oh, there we go. Man, that's that's a lot better. So, okay. Yeah, as far as this goes, it's all good. Just need to figure out this at a later time. But everything is fantastic now. So I did have to put in a few more conversion strips. If you're not familiar with what these are, they're just a little magnet here on the end of this little... There's a magnet here, and it has an adhesive thing you peel off, and you can stick it here in the yoke and stick it to the tube and make your adjustments for your convergence. I went through and did a little bit more fine-tuning with these. I didn't mess with that at all. Focus. I hate this phone. I didn't mess with those at all. So I went through and did a little bit more fine-tuning with the convergence strips. But I mean, it really is just fantastic. It might be a little bit too blue through the camera, but in person, it's perfect. I'm still just mystified by these, but we'll get to that some other time. Yeah. Focus. Yeah, anyway, you get the idea. So, that being said, we have successfully repaired this, brought it back to life, did the adjustments, did the yoke swap. We now have a perfectly good working tube, and everything is great. So once we find a frame for this, it should be ready to go in any medium res 19-inch game that I want to put it in. And yeah, that's going to be awesome. So I might put it in Paperboy, but I'd like to do another tube swap with the Paperboy, find another CR23 19-inch tube, because the only other spare commercial TV I have is a 7-pin CR31 and that Paperboy K7000. Oh, you know what? I can convert that CR23 neckboard to a CR31 neckboard and use the other spare commercial TV tube that's a CR31, and I can do a Paperboy tube swap for that. Yes, I think that will be done in the future. That's what I'm going to do. Okay. Thinking on the fly here, I realize we can do that. So we're about to have two tube swapped medium res monitors. So stay tuned for that. I got a lot of other stuff. I got a U5000 coming to me that had a whole corner broke off in shipping that they want me to repair for them, and that'll be fun trying to get that fixed up. But yeah, so stay tuned for that. That's coming up next, I believe. But for now, we got this all done, and you saw what to do and everything that entails with this. So if you have questions, make sure you post down below, ask away. I'll be glad to help out and let you know. But otherwise, yeah, thank you very much for watching. I appreciate it. Make sure you like, share, and subscribe, and we will see you next time.